Now the lecture topic for today's lecture is spread spectrum. So first of all, what is a spread spectrum? Can anybody know about it? And what do you mean by spread spectrum? Yes, anyone? So this spread spectrum, when we have multiple signals coming over to the multiplexer, so we use spread spectrum that will combine the signals from different sources to fit into the larger bandwidth. And similarly, when our goals are different and we need to differentiate that signals now over a single link, that is called the spread spectrum. So this spread spectrum, as says, we combine signals from different sources to put into a larger bandwidth, but our goals are to prevent eavesdropping and jamming. Eavesdropping means uh, देखो कई बार क्या होता है हम एक यूज करते हैं वर्ड दीवारों के भी कारण होते हैं तो दैट दीवारों के कारण मींस ईवसड्रॉपिंग मींस समवन is looking for the information that you are sharing with someone on phone or via talk or via something else, and then there is a jamming. So if the jamming is there, that means the signals will not reach to the receivers at a particular time or at a specific time. So our goal is to combine the signals as well as to prevent from eavesdropping and jamming. To achieve these goals, spread spectrum techniques are used using the redundancy. So the signal that occupies a bandwidth of B is spread out to occupy a bandwidth of B spread spectrum. All signals are spread to occupy the same bandwidth. Signals are spread with different codes so that they can be separated at the receivers, and signals can be spread in the frequency domain or in the time domain. So in this spread spectrum, we spread the original spectrum needed for each station. If the required bandwidth for each station is B, then the spread spectrum expands to its BSS. So the expanded bandwidth allows the source, okay, to wrap its message into a, you can say, a protective envelope, like we whenever we send a letter to our relatives in the old days, we wrap up it in the envelope for secure transmission so that no one will be able to read our message to our relatives. Okay, so the methodology in sending a message or gift, we can insert the gift in a special box. So like we whenever we give the boxes to, or whenever we give the gifts to our relatives or friends, so that means we we wrap it up in a box, as well as we wrap up in the gift paper so that he or she will not be able to see it immediately. Later, whenever they unwrap it, they are able to see it. So basically, this is the using of spread spectrum. So this is, suppose this is the signal of B, and spreading process is there, and it will implement the spreading code, and see it is shown like this. That means the signal is being spreaded so that it cannot be in readable form to the other devices. Means this signal, suppose this is a signal and we are spreading it in this way. So signal, first is the frequency hopping spread spectrum. This this signal broadcast over random series of frequencies. So receivers need to differentiate between these frequencies in synchronous with the transmitter of the sender. So, and we also have to get rid of the eavesdropper as well as the jamming. So shortly it is also called as FHSS, frequency open spread spectrum, uses different carriers frequency that are modulated by the source signals. So at a single point of time, the signal modulate one carrier frequency, and similarly at the next moment the signal modulate another carrier frequency. It means the frequency is continuously changing on, means at a one point, now suppose if this is the spread spectrum, these two modulations are being used, and at one point, suppose the one is coming and two is coming, and similarly at this point one is the frequency and here is two is the frequency, while at the second modulator that two may be one, here two, and this is one. So that means at the next moment the signal modulates another carrier frequency. So this is done using one carrier frequency at a time, and we will use the M frequencies in the long run. So number of modulators are we are using, the number of signals will be modulated. So typically 2 raised to power k carrier frequencies are forming 2 raised to power k channels. So number of carrier frequency are there. So number of channels that will be made. So channel spacing correspond with the bandwidth of the input. So that will totally depends upon the bandwidth of the input. So each channel, if you use the fixed interval, 300 milliseconds is IEEE 802.11. So some number of bits transmitted using an encoding scheme, maybe fractions of bit or maybe sequence dictated by the spreading code. So see, this is the original signal, and one modulator is being used. At this modulator, the frequency synthesizes is there. A pseudo random code generator called pseudo random noise creates OK bit pattern for the every hopping period, and if that signal is okay, it will create the hopping bit pattern for okay signal. So the frequency table, this frequency table, it uses the pattern to find the frequency to be used for this hopping period and passes it to the frequency synthesizer. So the frequency synthesizer, what it will do is it will create a carrier signal of that frequency, and source signal modulates the carrier signal, and that will be spreaded over the link. Clear? So this is the first action k bit patterns and frequency table is being used. So k bit is 000. So for this we have 2 kilohertz. Similarly for 111 we have 900 kilohertz. So these are some cycles, and some different hopping periods are there. So this is the bandwidth sharing for FDM and frequency hopping spread spectrum. See, in frequency division multiplexing, they are using the same frequency, but in frequency of being spread spectrum, it is being spreaded to different locations. Clear? So next is direct sequencing spread spectrum, DSSS. Each bit is represented by multiple bits using spreading code. So in this, each bit is separated into the multiple bits. So for this, that means the signal or the bit is being spreaded. So spreading code spreads the signals across wider frequency band. So in proportion to the number of bits used, 10 bit spreading code spreads signals across 10 times bandwidth of the 1 bit code. Means 1 bit will be spreaded to 10 times, means 10 bits spreading code. Okay. So it also expands the bandwidth of the original signals, but the process is that it will use the multiplication of a single bit. So not only 10, but you can say that in this DSS spread spectrum, we will replace the data bit with n bits. Okay. So the example we have discussed is here n is 10. So the 1 bit is converted or spread to the 10 bits spreading code. So one method is combine input with spreading code using XOR gate. It input bit 1 inverts the spreading code bit, and whereas the input 0 bit doesn't alter the spreading code bit. So data rate will be equal to the original spreading code, and performance will be similar to the FHSS. So one method is similar to the FHSS, in which on 1 bit we are using the XOR gate and 0 bit doesn't alter. So in this, the chip generator is being used. The original signal is transferred to the modulator, and modulate at the modulation.